here's the relationships that we want to know. If we have a triangle, from the perspective of this angle, this side is your opposite, or in other words, the y height is your opposite. Your adjacent side, we can think of it as x, and your hypotenuse. Okay, so sine, cosine, and tangent are our standard three trig functions. So sine of theta, cosine of theta, tangent of theta. Your input is an angle. The thing that this function of your angle is, the thing that transforms out of your sine, cosine, or tangent is a ratio. In the case of sine, it's opposite over hypotenuse. In the case of cosine, it's adjacent over hypotenuse. And in the case of tangent, it's opposite over adjacent. So let's look at the cosecant, secant, and cotangent relationship that goes with those. So sine, when we flip it, when we turn it upside down, we get cosecant. Cosine, when we flip it and turn it upside down, we get regular secant. And tangent, when we flip it upside down, we get cotangent. So we're still inputting angles, and what we're getting out is still ratios, but it's just the flipped ratios. Whereas sine was opposite over hypotenuse, the related one, cosecant, is hypotenuse over opposite. Whereas cosine was adjacent over hypotenuse, the related one, secant, is the exact flip, the exact reciprocal, hypotenuse over adjacent. And for cotangent, whereas tangent was opposite over adjacent, cotangent is adjacent over opposite. Okay? So, this same triangle, the same setup that we drew, represents both of these. Your output for both of these is still a ratio. Output is still a ratio. The ratio of which sides we're looking at has just been flipped when we go from sine to cosecant, or when we go from cosine to secant, or when we go from tangent to cotangent.